Hello everyone, we are at Beyond the Formula. Let's discuss equation of a plane that is in three-dimensional geometry. Y equals mx plus c. Now in 2D, every line has an equation, right? In 2D or two dimensions, this is the equation of line. Equation of line in 2D, that is in slope intercept form. Now, but what is the equivalent of line in 3D? We have a point in 1D, right? In one dimension, we have a point. When point is stretched in 2D, it becomes a line. So we have line in 2D, and when that line is stretched in 3D, it becomes plane. So we have plane in 3D, right? We have a point. Then when it is stretched in 2D becomes a line, and when this line is stretched in 3D becomes a plane, right? So how do we write the equation of plane? How do we write the equation of this plane? Equation of plane. So first let's draw a plane and think. So we have a plane here. This is a plane in 3D. Now what information do I need? What information do I need to completely fix this plane in a space, right? So if it is a general plane, it will move in three dimensions. It can be moving in say xy plane, yz plane, xz plane, or maybe with a angle with x-axis, y-axis, z-axis. It can be anything, right? If we say we draw it, so this plane can be like this plane can be here like this. So before writing the equation of a plane, what we need to do, we need to fix this plane in space. So what we only need is 3 points, right? 3 points. We need 3 non-collinear points or 2 intersecting lines. We need either 2 intersecting lines or 3 non-collinear points, A, B, C, or line L1 and line L2. Another important point here, is there any simpler way? Is there any simpler way? A plane is completely determined by a a point, and if I say we have this plane, if I have a point on the plane and a perpendicular vector that is the normal to the plane, now if I have these 2 points, these 2 conditions, if I have a point and a plane normal, so if I say there is a plane, say P1, it passes with the point A and perpendicular to this vector, say n cap. It is perpendicular to n cap or n vector. So now this planes become stationary. Now it cannot move. Think, can this plane move? No, this plane cannot move, right? If it moves, keeping the angle 90 degree with the normal, it will lose the point A, or if it holds the point A, it will lose what? The 90 degree angle with the normal. So now we have got two fixed conditions here. Point A with coordinates x1, y1, z1, and a normal vector n vector. We have n vector as ai plus b j cap plus c k cap. Now, as we studied earlier, that what we need to do, just we need another general point P on the plane and just develop a relation between the given parameters and the general parameters. Here P will have the coordinate x, y, z, that is a general point. That is a general point on the plane. Now P can lie anywhere on the plane. Now you see, we have a vector here. We have a vector here. PA vector or AP vector. Doesn't matter. You can have PA vector, you can have AP vector. Doesn't matter. But the important point here is what? That PA vector is perpendicular to N vector. Right? We have PA vector perpendicular to N vector. Right? And if PA vector is perpendicular to N vector, we can use dot product between the vectors, because it will include what? Cos theta, and cos theta, cos 90 is 0. So we have PA vector perpendicular to N vector, so we can write PA vector dot product with N vector will be 0, right? Why? Because PA vector is perpendicular to N vector, which implies there is 90 degree angle between them, and the cosine of 90 degrees is 0. So we will have PA vector dot N vector equals 0. So let's write PA vector. So we have PA vector as x1 minus x I cap plus y1 minus y j cap plus z1 minus z k cap. Right? This is PA vector dot product with A I cap plus B j cap plus C k cap, and which is equals to 0. So in dot product, what we do is we just simply multiply the I coefficients, j coefficients, and k coefficients. So we have A times x1 minus x plus B times y1 minus y plus C times z1 minus z equals 0. Correct? Now we have ax1 minus ax plus b by 1 minus b by plus cz1 minus cz equals 0. So we can rearrange it as ax plus by plus cz minus ax1 minus ax1 plus by1 plus cz1 equals 0. Now you can take this whole value as d or minus d. So you will have ax plus by plus cz plus d equals 0, which is the equation of plane, right? Equation of plane. Now this is not just a formula that appeared from nowhere, right? It is simply what? The mathematical statement that every point on the plane produces a vector that is perpendicular to the normal vector of the plane. correct? So what we can conclude here is, in 2D, a line is determined by normal vector and a point. Similarly, in the case of 3D, the plane is determined by a normal vector and a point. Thanks.